Hello and welcome to my channel. In this video we will be looking at the role of hormones in sex and gender, which you need to know for AQA A-level psychology in the subtopic of gender. I hope you enjoy this video and find it helpful. Let's get started. Hormones are chemicals produced by glands in the body that travel through the bloodstream to affect the activity of cells and organs. While all humans produce the same hormones, males and females produce them in different quantities. Developmental role. In the womb, hormone levels influence brain development and determine the formation of male or female genitalia. At puberty, rising hormone levels trigger the development of secondary sexual characteristics, e.g., breast development in females, facial hair growth in males. Gender development. Differences in hormone levels, e.g., higher testosterone in males, higher estrogen in females, contribute to physical and behavioral sex differences. These hormonal influences are linked to sex role stereotypes and play a key role in shaping gender identity and behavior. Testosterone. Testosterone is the primary male sex hormone, though females produce about 10% of the amount found in males. It is a steroid hormone responsible for prenatal development. Around 8 weeks of gestation, the SRY gene on the Y chromosome causes the gonads in XY embryos to develop into testes. These begin producing testosterone, which drives the development of male sex organs and masculinizes the brain. A testosterone surge occurs between weeks 8 and 24, followed by a drop until birth. A second surge happens during the first 6 months after birth. Physical effects. Testosterone influences the development of secondary sexual characteristics during puberty, such as body hair and a deeper voice. Psychological and behavioral effects. Testosterone contributes to traits like spatial skills, aggression, and competitiveness. High levels are linked to aggression, which may have evolved to help males compete for mates and protect territory. Brain development. Testosterone affects brain structures such as the hypothalamus, with the sexually dimorphic nucleus being larger in males. It may also be linked to reduced emotional sensitivity, although this is debated. Estrogen. Estrogen is the primary female sex hormone, with estradiol being the most common form. While produced in smaller amounts in males, women typically have around 10 times more estradiol than men. Prenatal development. In embryos with 2X chromosomes, the absence of the SRY gene leads to the development of ovaries instead of testes. This results in higher estrogen and lower testosterone levels, contributing to the feminization of the brain. Physical effects. Estrogen regulates the development of female reproductive organs, e.g., fallopian tubes, ovaries, vagina, and secondary sexual characteristics such as breast development. Menstrual cycle and emotional changes. Estrogen plays a key role in regulating the menstrual cycle and is linked to emotional and behavioral changes during this time. These include symptoms of premenstrual tension, PMT, or premenstrual syndrome, PMS, such as increased irritability, emotional sensitivity, and sometimes irrational or antisocial behavior. Brain development and behavior. Estrogen is believed to feminize the brain by promoting greater neural interconnectivity and balanced use of both hemispheres. This may support traits such as sensitivity and cooperation. Oxytocin. Oxytocin is a polypeptide hormone and neurotransmitter, often referred to as the love hormone due to its role in bonding, trust, intimacy, and social behaviors. It is produced in the brain and pituitary gland in both sexes, though its effects are typically stronger in women due to the amplifying influence of estrogen. Biological functions. Stimulates uterine contractions during childbirth. Promotes milk release during breastfeeding. Encourages mother-infant bonding by increasing emotional connection and reducing cortisol, the stress hormone. Psychological and social effects. Facilitates bonding, nurturing, and social connection in both romantic and parental relationships. increases during sex in both men and women, about 5x, but drops sharply in men after orgasm, possibly explaining differences in post-sex intimacy. Contributes to the tend and befriend stress response in women, whereas testosterone may inhibit this effect in men. Gender differences and stereotypes. Women generally have higher oxytocin levels, particularly during and after childbirth. This may help explain traditional gender stereotypes around caregiving, emotional sensitivity, and sociability, though both sexes produce similar levels during bonding activities. Evaluation of the role of hormones in sex and gender. A strength of the role of hormones in sex and gender is that there is robust evidence supporting their influence even in adulthood. For instance, Wang et al., 2000, treated 227 men with hypogonadism using testosterone therapy. Over 180 days, participants showed significant improvements in sexual function, libido, mood, and muscle strength. This demonstrates that testosterone has a powerful and direct influence on both physical and behavioral characteristics associated with male sex and gender identity. A limitation of the role of hormones in sex and gender is the presence of conflicting evidence. For example, O'Connor et al., 2004, conducted a double-blind placebo study in which testosterone was administered to healthy young men. The researchers found no significant increases in sexual behavior or aggression. This suggests that in individuals with normal hormonal functioning, additional testosterone may not significantly alter gendered behaviors, challenging the idea of a straightforward link between testosterone and behavior. A limitation of the role of hormones in sex and gender is that it neglects the impact of social and cultural factors. Hofstede et al., 2010, argued that gender roles are more strongly shaped by cultural norms than biological processes. For example, masculine traits are more highly valued in individualistic societies like the UK and US. This suggests that gender behavior may be largely learnt through cultural expectations rather than solely determined by biological factors. A limitation of the role of hormones in sex and gender is that biological explanations are often reductionist. They focus heavily on hormones and chromosomes while ignoring other influences such as cognitive and psychodynamic factors. Cognitive theories highlight the role of thought processes like gender schema, and psychodynamic theories emphasize early family interactions. This suggests that gender development is more complex than what biological theories alone can explain. A strength of the role of hormones in sex and gender is the support from animal studies. For instance, Guadagno et al., 1977, found that female monkeys exposed to testosterone prenatally engaged in more aggressive and rough play. This supports the idea that hormones like testosterone influence gender-typical behavior. However, these findings must be interpreted with caution due to differences between humans and animals, including cognitive factors like free will. A limitation of the role of hormones in sex and gender is the challenge of generalizing animal research to humans. While animal studies provide valuable insights, humans have unique psychological and social influences. Eisneger et al., 2010, found that women who believed they had received testosterone acted more unfairly in a bargaining game, regardless of whether they actually received the hormone. This demonstrates the influence of expectations and belief, complicating direct causal claims between hormones and behavior. A limitation of the role of hormones in sex and gender is that it is overly simplistic to attribute complex gender behavior to single hormones. Hormones like testosterone, estrogen, and oxytocin interact with each other and with genetic structures like the SRY gene. This complexity suggests that gender development is the result of a dynamic system rather than isolated hormonal effects. A strength of research into hormones and gender is its practical applications in medicine. Hormone therapies have improved quality of life in various contexts. Testosterone is used to treat erectile dysfunction and low libido, including in postmenopausal women. Estrogen reduces the risk of osteoporosis and stroke, and oxytocin is used during childbirth to initiate and sustain labor. These real-world benefits show that understanding hormones can lead to significant health improvements. A strength of the role of hormones in sex and gender is support from cross-sex hormone research. Van Guzen et al., 1995, found that transgender individuals exhibited more stereotypically masculine or feminine behaviors when administered testosterone or estrogen, respectively. This supports the idea that hormones influence behavior associated with gender identity. A limitation of the role of hormones in sex and gender is that not all studies support a clear hormonal effect. Tricker et al., 1996, gave testosterone or a placebo to 43 men and found no significant changes in aggression. This suggests that testosterone alone may not explain aggressive behavior, especially in normally functioning adults. A strength of the role of hormones in sex and gender is evidence from atypical development. Studies on individuals with Klinefelter's or Turner syndrome show that differences in chromosomes and hormone levels are linked to variations in gender development. This supports the idea that hormones and genetic structures interact to influence gender identity and behavior. A limitation of the role of hormones in sex and gender is that they may reinforce harmful stereotypes. For example, small average differences in abilities such as spatial reasoning are sometimes wrongly used to justify discrimination against women in fields like engineering. This makes research into biological influences socially sensitive and ethically complex. A strength of the role of hormones in sex and gender is the case study of David Reimer, which illustrates the primacy of biology over socialization. Despite being raised as a girl after a medical accident, David eventually transitioned back to living as a male, showing that biological factors such as chromosomes and hormones can outweigh environmental influences in gender identity development. Thank you for watching. If you have enjoyed this video, please like and subscribe for more content like this. Bye.